got two new functions. This time the f function is 3x to the 1/3 power, and the g function is 2x to the 1/3 power, and we're going to create four new functions. One when we add, one when we subtract, one when we multiply, excuse me, and one when we divide. So the first thing I want to think about is kind of what these would look like. This means the same thing as 3 cube roots of x. And a cube root function graph looks something like this. This is also a cube root function, so it looks something like this. So if we think about the domain, we can put any number we want to in for x. Negatives are okay if it's a cube root. 0 is okay if it's a cube root, so are positive values. So since both of these domains are negative infinity to infinity, when I add them, they're going to add every place. When I subtract them, they're going to subtract every place. Same thing with multiply and divide. So I know on this particular problem, each one of these is going to have a domain of negative infinity to infinity. So I'm going to go ahead and write that in. Now, I'm going to wait a moment on this one, dividing, because divide is going to be the places where they intersect, but we may have to go back at the end and tweak this a little bit depending on what our problem looks like in the end. All right, so let's start with f plus g of x. You could write that as f plus g of x or f of x plus g of x. So I'm going to take the f function and add the g function. And this one is nice because they both have x to the 1/3 power, so that means that I have like terms, so I can add the coefficients. So my new function that's created is 5x to the 1/3 power. So what that would do on this one, it looks like, is it would stretch it out. Okay, let's talk about subtraction. And we did this addition and subtraction on the first day note sheet. So you saw how we would just take the output values and add them together. So this time I'm going to have the f function, and I'm going to subtract the g function, and that's going to create my new function. So the f function is 3x to the 1/3, and I'm going to subtract 2x to the 1/3, so I'm left with just 1x to the 1/3. So the new function that's created by subtracting the two functions is x to the 1/3. All right, let's think about multiplication. So basically it's like we're multiplying the output values, but we're going to create this new algebra function by multiplying the f function times the g function. And the f function is 3x to the 1/3 times 2x to the 1/3. And when we multiply functions like this, we have 3 times 2, which is 6, and x to the 1/3 times x to the 1/3, we add the exponent, so it would be x to the 2/3. So the new function is x to the 2/3. The last one is division. So I'm going to have the f function divided by the g function. The f function in this case is 3x to the 1/3. The g function is 2x to the 1/3. So what happens on this one is with division, all of a sudden we have got to look at our domain. Because during the middle of this problem somewhere, I put x, my input value, in the denominator. And so once x becomes part of the denominator, we have to think about numbers that we don't want to be in the denominator. And I'll try to drive this point home with more examples. So if you're a little confused at the beginning, that's okay. I never want to have 0 on the bottom of a fraction. And this means 2 cube roots of x on the bottom. So what number would I not want to put in for x to make this whole thing 0? And that number would be 0. But I've already said that the domain can be any number from negative infinity to infinity. But now I'm saying because I put x in the denominator, x can't be 0. So I have to cross this out and tweak it a little bit. Now I know that the domain can go from negative infinity to 0, but 0 doesn't work, so I'm going to skip over it, and go 0 to infinity. And now I can go back and keep simplifying here. The x to the 1/3 and the x to the 1/3 cancel, so my answer is just 3/2. So the new function that's created is 3/2, and that would just be a horizontal line at 1 1/2.